Alright, this is video homework number 2. You can see the remnant of video homework number 1 above. If you haven't worked number 1 yet, don't look at it. Go away and work number 1. Okay, in number 2, same thing as in number 1. Tell me what the product is. Tell me if the reaction is SN2 or SN1. It's one or the other. Alright, hit pause, go do that, come back. Okay, so if you're back, look at all the molecules again, this reaction arrow scheme. Basically you have this compound plus all of this. Typically it's going to be the organic thing, the stuff with carbon in it we're interested in, and then whatever reagents that are doing the transformation. So we've got a leaving group in iodide. Then do we have a nucleophile? Where is a nucleophile? DMF is one of the solvents you're supposed to know. Dimethylformamide. It's a polar aprotic solvent. It's good for supporting SN2 reactions. It's quite polar. It's comparable to water in polarity, but it can't be a hydrogen bond donor. Okay, potassium azide. Potassium, you should see immediately as +1. That means the N3 is -1, and in fact, azide looks like that. Nice little bullet-shaped nucleophile. So azide is a nucleophile. It's one of the nucleophiles. It's not a very strong base. As an interesting aside, HN3, so if you protonate azide, HN3 is about as toxic as cyanide, and it's also explosive. Good times. So anytime you're ever going to work with azide, try to avoid having strong acids around. Okay, back to the point. Nucleophile, leaving group, electrophilic carbon. It's a primary carbon, so you can do SN2 on it. Got a solvent that supports SN2. This is going to be an SN2 reaction. Let me get rid of some of this extraneous stuff. So you get the allylic azide and potassium iodide. You can then go ahead and reduce the nitrogen, whatever that would be, the azide, to a primary amine. So you can kick off N2 and be left with an NH2. It's a nice way to make amines that you'll see in second semester organic. Okay, I'm going to do a separate video for number 3.